before we went on winter break here, we were doing this business with rational functions or reciprocal functions, and they look like these right here. And we just did real simple ones. Now, what these mean right here, when you see f of x, that's really just the same thing as, you don't need to write this, just look up here, y. And this would be the same as y equals x over 2, and this would be the same as y equals x over 3. Okay, that's what they look like, and they had two branches. They were in the first and the third quadrant. Now, a reciprocal function, what that tells you is if I took this equation and I multiplied both sides by x, this equation right here is the exact same thing as x times y equals 1. I get the same thing here. This means x times y is 2. And this one would be x times y is 3. These two things are the same, just written differently. So when you have a reciprocal function, if you pick a point on this graph and you take the x coordinate times the y coordinate, what's it going to equal on this first graph? What's the product of the x and the y coordinates going to be? 1. If I pick any point that's on this one, for example, that point's 2, 1. When I take 2 times 1, I get 2. So every x coordinate and y coordinate on this graph, when you multiply them, you're always going to get 2. Any point that I pick, no matter what point it is, it doesn't matter if it's in the first quadrant or the third quadrant. If I take the x coordinate and multiply it by the y coordinate, I get 3. Anytime where you have something like that going on, you can create a reciprocal equation for this graph. Okay. And then what we learned was, as the number on top got bigger, the graph moved away from the origin. So for each one of these, as the top number got larger, the graph got further and further away from the corner, because these numbers vertically stretch the graph. This vertically stretches it by a factor of 2. This vertically stretches it by a factor of 3. If any of those top numbers were negative, all it did was take the graph and switch it to quadrants 2 and 4. Okay, that was a flip over the x-axis. That's what this does. Flips it over the x-axis. All right, so what we're doing today is, let me do one other thing. When you look at this table here, now let's say you couldn't see this. This was covered up, and this was covered up, and this was covered up. And I said, write an equation that generates this table. Well, if you take these two numbers and you multiply them, you get 4. Same with these two. Multiply those two, 4. Multiply those two, 4. Anytime I take the x and the y coordinate and multiply them, I always get 4. That's how you know that this is a reciprocal function, because x times y is 4, so y is the same as 4 over x. That's how you know you got a reciprocal function in your table, by looking at the x and the y coordinates. And when you multiply them, they're always the same, then you've got yourself a reciprocal. All right, so we're going to use that to model some problems and come up with solutions from them. And we're going to solve the problems using our graphing calculator and then also without. All right, so what we got here is this parking lot, and we're designing it, and the area has to be 800 square feet. And the students decide that it'll be rectangular, and now we got to decide what's the length and the width going to be. All right, so our width is going to represent the x coordinate. So up here, I'm going to put width. That's going to be represented by the letter x. And when I multiply it by the length, that's going to be represented by y. I'm going to get 800. Okay, so this is an equation, x times y is 800. Now, if I solve this for y, so I'm going to solve for y in terms of x, right? So to get this, what I would do is I would divide both sides by x. So I would have this, divide by x. And now I have the reciprocal form of my, okay? This is a reciprocal function. Where x is the width and y is the length. Now, really, when you make a table, we get used to putting the x's on the top. So we're going to get, I should have switched these. I'm going to get rid of that, cover that guy up. And we're going to say the top row is the width. And get rid of that guy. And we'll make the bottom row the length. That's just typically how you set up your table. X is on top, Y is on the bottom. So if we fill in Y values and we divide 800 by them, or excuse me, X values, and divide them into 800, we're going to get the Y values. So these are going to be just different widths that I could use in my parking lot. And I'm just picking these randomly as long as they go into 800. So like I know 10 goes into 800. So this would be 800 divided by 10, so that would have a corresponding length of 80. 5 goes into 800. Okay, that would be 800 divided by 5, which would be 60. So I'm just coming up with numbers that make 800. Um, 800 divided by, oops, darn it, my calculator's acting funny today again. Okay, let's just come up with some others. Give me some pairs that'll make 800. 4 and 200, yeah. 40 and 20, yeah. So all of these are going to end up on our graph once we graph this thing. What else? Let's see. 8 and 16 and 50, yeah. 8 and 100. 1 and 800, that'd be pretty narrow parking lot. What else? One more. Very good. 32, 25. Okay. All right. So, and we could pick, like 10.5, but all of these numbers, the whole point here is if you look at the product of these numbers, the product is always 800. So that's how you know you've got a reciprocal function. How can you tell from a table of values that a real life situation could be represented by a reciprocal function? The product of the x and y coordinates is the same. Or it's constant. In this case, it's always 800. So I recognize that, so I know I can write this as a reciprocal function, which we already did. Okay. All right, so now what you're going to do is you're going to go to your calculator, and like I said, my calculator's acting weird right now. Let me reset it. Oh, got it to work. Okay. So we're going to go y equals 800 divided by x. And when you graph it, if you hit zoom and you say zoom 6, that puts it on a regular 10 by 10 graph. And you notice you don't see anything. Okay. So what we have to do is change the window. So press window. Okay, now a little bit of common sense here. Since we're dealing with real life, we only have to worry about quadrant 1. Because you can't have negative width and you can't have negative length. Okay, now what I'm going to do, and what's critical when you're graphing these and drawing your graph, is that you label what these axes are. That's X, that's Y. All right. Are you playing Animal Crossing right now? That looks like Animal Crossing. Oh, that's just about as good. Okay, can you focus on this temporarily, and then you can go back to feeding the animals? Okay. My daughter's like addicted to Animal Crossing. I don't get it. I don't, I don't get what you get out of that, but she loves it. And she's like 19. Yeah. All right. I'm like, what? You don't blow anything up in it. How can it be any fun? All right. Okay, so where was that? Okay, X in this case, up here, we said X is the width. So X is the width, so I'm going to write down here width. And then you put what the units are, in this case, meters. And so the y is the length. And that's also in. Now, without that, guys, your graph doesn't mean anything. You have to make sure that you label your X and Y axes. Okay, now what we have to do is get an idea what kind of scale we want to use on these axes. And really, a lot of it's just playing around and seeing which one gives you a nice picture of the graph. All right. So if we go back to that, okay, for our X minimum, we don't need any negative numbers. Now, I usually just make this like a -2 so that I can see the axis, but you could make it 0 if you wanted to. Okay, now X max. So when I'm looking at this list of data here, oh, I got like 2 is the smallest, 32 is the largest. So maybe go out to like 50. And you can change this once we graph it. But now I'm going to go down and change my X max to 50. And then what I always do, so I have 10 tick marks, as I divide that number by 10. That's my scale. Okay, now the Y, I'll make this guy -2 again. So I can see the axis. Okay, and now when I look at the Y coordinates, I got a 20 and I got all the way up to 400, all the way up to 800. Okay, so we'll go like up to 800 or 1,000 and we'll see what it looks like. So I would now count by 100s. And we'll see if this gives us a decent picture. Yeah, not bad. Okay. So we're going to take that and draw it. That's fine. That guy, and there's our graph. Okay, now what you're going to do on this graph, let's see, we got X and Y, is on this graph, I'm going to write Y equals 800 over X. And any point that I pick on here, whatever those coordinates are, when you multiply them, you're going to get 800, even if they're decimals. All right, so if I go back to this and I hit trace, any point on here, if I took those two XY numbers and multiplied them, I would have an area of 800. Those two would give me an area of 800. These two would give me an area of 800. So this is all the possible values I could make my parking lot. Okay, so the next part says for a car park to fit alongside the back entrance of the school, the length has to be twice the width. The length equals twice the width. So y equals 2x. So it says write this criterion as an equation in x and y. We just did. Y equals 2x. And then plot the graph on the same axis as your original. Okay, so you open up your graph, y equals, and go down to 2 and make it 2x. And graph it. Okay, so okay. So now your graph looks like this. Okay, and just label on it. This is y equals 800 over x. And then the red one is y equals 2x. Now, where do you, so every point on the blue graph, okay, if I take that x and I multiply it by that y, I get 800. Okay, every point on the red graph, these numbers, if I take whatever the x coordinate is and I multiply it by 2, I'm going to get the y coordinate. Okay, so what pair of numbers, where would I look on that graph, guys, to find a pair of numbers where the length is twice the width and the product of the two numbers is 800? Where do you look for it on that drawing? So here's what you want to find. You want to find a point whose x times y equals 800 and whose y coordinate is twice the x coordinate. Where would I find that special point that satisfies both of those? If it's on the blue, it satisfies the top one. If it's on the red, it satisfies the bottom one. So where do I find the one that satisfies both? Yeah, where are they? The intersection. Yeah, Zach is right there. Okay. Boy, I didn't hear you. Look, I didn't karate chop you. I didn't even hear you come up. Pretty stealthy. Yeah, I was always. And then I realized, oh, God, you could have came up and robbed me, and I wouldn't even known it. Okay.
You do have this power.
Yeah, take my Powerade, and I wouldn't have even known it. Okay. So let's see, where was I? Okay, so to do that, guys, we go to intersect. So we go second, calc, go down to intersect. Okay, now watch the keystrokes here. They're very simple, but for some reason, people always get confused. Okay, if you look in the upper corner of the graph, this tells you where your cursor is. Your cursor is on the blue curve. That's the first curve. So you just hit enter. You want to find the intersection with the line, which is the red one. So since it says y2 is 2x up here, that means the cursor is on the red line, so you hit enter. Then you're going to move your cursor to where you think the intersection is and hit enter. And there is that's the point that satisfies both conditions. Okay, so okay. All right, so let's write what we did. To solve this graphically, we graph both functions and find the intersection. So we graph 800 over x, and then we graph y equals 2x, and then we find the intersection. And our intersection was 20, 40. Okay, so let's see, 20 is the width. So our parking lot is going to be 20 meters wide by 40 meters in length. Okay, that's using the graph. All right, now you could also solve it using algebra, which is a little quicker. Okay, what you do is you set your equations equal. So I put 800 over x equals 2x, and I solve it. I multiply both sides by x, divide both sides by 2, and then take the square root. I get x equals plus or minus 20 meters. Okay, now you can see that you can get rid of the negative because you can't have negative length. So I don't have to worry about the negative answer. Okay, so I know my width is 20, and then I can get my length by doubling it. So we could answer the question geometrically, or we can answer the question algebraically. Okay, we'll set up this last one and then you solve it. Because we might run short on time here. All right, so Adam's got a mobile phone. Okay, well, so that tells you right now it's a pretty old problem. Nobody calls it mobile phone. And it's got a limited amount of free space to store photos. It only has 240 megabytes, which is like nothing to store photos. Yeah, this is an old problem. Okay, the phone settings allow Adam to choose the default size in megabytes, and then the photo size is the amount of space that each photo occupies on the phone. Okay, so basically what this is telling you is if you take the size in megabytes and you multiply it by the number of photos, you can use up to 240 megabytes. Okay, so what we're going to do is we're going to let x equal megabytes and y equal the number of pictures. And there's your equation. This is x, this is y. And when you multiply them, you're always going to get 240. So that allows you to fill in the table. All right, to get your equation, folks, write down the equation for y, the number of photos Adam can store on his phone in terms of x. Okay, so I know that y, or x times y, is 240. Now solve that for y. And there's my equation. So that's what you're going to end up graphing. Okay. Now, before you even graph, label your axes. Let's see. X was the size, so X is megabytes. Y is number of pictures. And you're going to type in Y1 240. And this is what I used for the max and min, since we're almost out of time here. Use that for your max and mins. Okay, and I'll just write in here the last part and then you can finish it. To solve this graphically, you're going to find the intersection of these two graphs. It says, what size picture will allow him to save 50 photos? Photos are Y's, So my second equation is going to be y2 equals 50. Okay, find the intersection. And then down here, set these two equal and solve for x. Okay, so finish this up. When you're done, you're going to have a line going through it like at y equals 50. And you want to find this intersection. Okay, so I'm going to set my window to these dimensions. There's our graph. And now I want to find the intersection. First curve, enter. Second curve, enter. And then there's my intersection, 4.850. Okay, so to answer our question, find the maximal individual photo size. Okay, that would be the x coordinate. So my answer is going to be the max photo size is 4.8 megabytes. Okay. Now, if I did this one, if I solve this for, if I take this equation and I solve it for x, multiply both sides by x, divide by 50, and we get 4.8. All right, so your assignment is 4C, 1AB, and you can do the work right here. So I set it up so that you can do the work on all of these, set up the graphs for you, gave you the window that you need when you're graphing them so they all look the same. And that'll be due on Wednesday, January the 6th.